20 sextillion. Where do you think a number of such orders of magnitude can be found in our cosmos? Could it be the sum of every star? Maybe every solar system and galaxy? Or perhaps it's the number of atoms in the observable universe? Before you continue to ponder that question, however, let me put this vast number into perspective. According to several scientific studies, the Earth has approximately 7.5 sextillion grains of sand on its surface. This includes every beach, desert, and riverbed on the planet, but it still doesn't manage to come close. Even if you went and doubled that mind-boggling amount of sand, you'd still fall considerably short of 20 sextillion. With that in mind, I'll rephrase the question I posed at the beginning of the video. What amount of anything in the known universe can a number so unfathomable, so entirely incomprehensible account for? That, my fellow cosmonauts, is what I'm setting out to answer in this video as we explore the question that inevitably follows when faced with a number such as this. How big is the universe actually? Before we venture too far out into the cosmic unknown, though, let's ground ourselves in a place we all know, our own solar system. Speaking of, what better place to start than the celestial body that holds everything together, our Sun? As I'm sure anyone who's been through elementary school already knows, our solar system consists of the Sun, 8 planets, moons, and various smaller bodies, such as asteroids and comets. While the Sun itself is ginormous compared to Earth, around 330,000 times more ginormous in fact, it's considered relatively average when compared to other stars in the Milky Way. Sirius A, for example, is 2 times larger than our Sun, while a star like Betelgeuse is 950 times larger than our Sun. A fact that's just that much more stunning when you remember that our Sun completely dwarfs everything else in our solar system. Who knows, we may even discover stars in the future that make Betelgeuse seem small in comparison. It's at the very least possible, especially considering that there may be an estimated 400 billion stars in the Milky Way. However, it is crucial to remember that size isn't the only factor that shapes our understanding of the universe. How we measure the space that separates these stars and planets on the imperial theater is just as important as their dimensions. This brings us to another pivotal aspect of our universe, light years. While astronomical units are far too small to measure any distance outside of our solar system, light years don't share that same issue. Since light is the fastest thing in the universe, a light year is the distance light travels in, well, a year, which is about 5.88 trillion miles. To contextualize this, if you could travel at the speed of light, you could circle the Earth about 7.5 times in just 1 second. Needless to say, it's not hard to see why they're used as a universal unit in astronomy. But now that we have a way to quantify immense stretches of space, let's revisit our solar system and develop a sense of scale that we can build on. Using the Oort cloud as a border, our solar system measures approximately 30 trillion kilometers, or 18.6 trillion miles. That's over 3 whole light years across, which is astonishing to say the least. To help you grasp how extensive this distance actually is, let me use another example. Traveling to the moon and back would see you traversing about 477,710 miles. Divide that against 18.6 trillion miles, and you'd be able to take a round trip to the moon over 38 million times. Anyway, having established the extent of our solar system, let's continue our journey. As we venture outward and away from our immediate galactic neighborhood, we find the second closest star to us, Alpha Centauri. While the star system doesn't offer much in terms of size and luminosity at just over 4 light-years away, this stellar system represents our closest neighbor in the dark expanse of space. But for all that, even at the speed of light, it'd still take any spaceship that somehow managed to get around the mass problem 4 years just to reach Alpha Centauri, and 4 more years to get back. And it's still essential to remember Proxima Centauri is just a stone's throw away on the cosmic stage. Our own galaxy, the Milky Way, is 100,000 light-years across, and it would take the same amount of Earth years to cross from one side to the other. If it somehow hasn't begun to set in for you already, this is where we truly begin to recognize the scale of our universe. Light, as fast as it is, still takes years, centuries, or even tens of thousands of millennia to travel across the vast distances between stars, let alone galaxies. Now, let's zoom out further and get a sense of how our galaxy fits into the larger universe. The Milky Way belongs to a small cluster of galaxies known as the Local Group, aptly named this because it's the entirety of our galactic neighborhood. The Local Group contains over 50 galaxies, notable ones including our very own Milky Way, Andromeda, and the Triangulum Galaxy, among others. The Local Group spans about 10 million light-years, which would be about 1.88 trillion times the distance from Earth to the Sun. That's still a drop in the bucket compared to the total observable universe, but I'm sure you could guess that already. This brings us to the Laniakea supercluster, a vast collection of galaxies that includes our Local Group and spans over 520 million light-years. To give you an idea of that scale, 520 million light-years is equivalent to about 5,600 times the distance from Earth to Alpha Centauri. It's one of many superclusters in the universe, all connected by gravitational forces. Yet, even superclusters, as beyond comprehension as they are, aren't isolated. They exist within an even more complex, vast web of galaxy clusters, filaments, and voids. The universe, in a way, can best be compared to a giant cosmic tapestry, with galaxies scattered along strands of matter and huge empty voids in between. As we conclude this exploration, let's take a moment to acknowledge the vastness of the universe one last time. Its sheer scale can often feel overwhelming, and I understand this sentiment very well. However, I also recognize that despite being just one among countless celestial bodies, each of us holds a specific place on this earth. Our lives, with all their intricacies, contribute to the complex tapestry of existence that we experience in the present moment. While the distances between galaxy clusters may stretch far beyond our comprehension, our connections with one another on this planet profoundly ground us. We are all part of a continuum of life where every moment, a shared smile, a helping hand, or a simple act of kindness holds significance. In times of uncertainty or doubt, remember that while the stars may seem distant and unattainable, the people around us and the relationships we build as a result of that are right within our reach. As you navigate your journey, keep in mind that your experiences, dreams, and passions contribute to the narrative of humanity. You have value, and your presence impacts those you share this earth with. May you find peace in understanding that fact, no matter how vast and indifferent the universe may seem. That's why I encourage you to keep looking around, engaging with those you hold dear, and finding meaning in the world beneath your feet. Neil deGrasse Tyson said it best: "We are all connected to each other biologically, to the Earth chemically, to the rest of the universe atomically." Embrace that connection, for it is through the bonds we form with those around us that we truly find our place in the cosmos. So, you've reached the end of the video. Hopefully, you found it insightful, enlightening, and ultimately valuable. If you have, don't forget to like, subscribe, and share this video with a fellow cosmonaut in training who may need a little reminder of how important they are. Until next time, this is New Horizons, signing off.